Factoring is another method that's commonly used for solving quadratic equations. We generally use the factoring method if the polynomial is easy to factor. So it's implied that the polynomial must be possible to factor, and generally we might not choose this method if it has really big numbers with lots and lots of factors, or if we're just not crazy about factoring. However, a polynomial that's easy to factor is usually most easily solved by the factoring method. So the first step is to move all terms to one side of the equation so that we have a polynomial on one side and 0 on the other side, or in the form polynomial equals 0. Then we factor the polynomial, and using the zero product property, we set each factor equal to 0 and solve those resulting equations. Looking at this example here, I can see that this 8x term is not where it should be. We want all the terms on one side. So my first step is going to be to subtract 8x from both sides to move it over to the left so that we can get this into the form polynomial x squared minus 8x plus 7 is equal to 0. And I went ahead and put these in order of descending powers in this step as well. The next step is to factor the polynomial. Because this one starts with an x squared, this is one of the easier factoring problems where we can usually get away with trial and error and just setting up two sets of parentheses. We know that each factor must start with an x so that when we multiply them together using FOIL, we'll get x squared for our first term. We also know that the numbers we put in the last positions here need to multiply to get 7. So they have to be 7 and 1 because 7 is a prime number. The only thing left to figure out are the signs. Because 7 is positive, they must both have the same sign. And because our middle term is negative, that means they must both be negative. We would do a quick check off to the side just to make sure that we've factored it correctly before proceeding. After verifying that our factorization is indeed correct, we can come back to the equation and set each factor equal to 0. So x minus 7 equals 0, and x minus 1 equals 0. And then solve each of these equations, in the first case by adding 7 to both sides, to get x equals 7, and in the second case by adding 1 to both sides, to get x equals 1. It's true that after using the factoring method several times, you usually can skip this step and go straight from a factor like x minus 7 to a solution like x equals 7 by recognizing the pattern of the sign change, and as we'll see with fraction solutions, what we do with the two numbers involved. So that our solution set here would be the two values 7 and 1. Now, not every quadratic equation that we see is going to have solutions that we find as easily as this one. Some of them are factorable, but maybe aren't as easy to factor as this one was. So let's just take a look at another example where maybe some students would choose to solve this by factoring, and others might choose to use the quadratic formula instead. It is possible to factor this polynomial using trial and error like we did in the previous example, knowing that we would have to start with 5x and x in our two binomials to make sure that when we multiply them together we'll get 5x squared as the first term. But then the different combinations that we have to consider get a lot more to think about in this example than in the previous one, because 8 could be 8 times 1 or it could be 2 times 4, and they could show up in either order. So we're going to instead look at what we sometimes refer to as the grouping method or the AC method, and that is based on this. If we have a quadratic equation or a quadratic polynomial in the form ax squared plus bx plus c, we can set up a diagram in which we put the product a times c in the top and just that middle coefficient b in the bottom. And then our goal is to find numbers on the sides such that when we multiply those numbers together, the product would give us the same number that we have in the top. And the sum would give us the number that we have in the bottom. So in our example over here, that a times c, well, we would have a equals 5, b equals negative 18. Remember, we always take the sign in front of the number. And c equals negative 8. My a times c would be 5 times negative 8, which is negative 40. That's what goes in the top. And b is that b is negative 18. So I get a negative 18 in the bottom of this diagram. Then my goal, as I said, is to find numbers that go on the left and right that are going to give me a product of negative 40 and a sum of negative 18. Because the product is negative, I know that they have to have opposite signs. It is not possible to multiply two positive or two negative numbers and get a negative result. So what I'm looking for is the choice of numbers that's going to give me negative 18 as a sum, and it looks like positive 2 and negative 20 is a good choice. We always want to make sure we check everything before coming out of this diagram, but those look like they work. And now I'm going to use these numbers to rewrite my polynomial. I'm going to keep the first term the same at 5x squared. I'm also going to keep the last term the same at negative 8. And I'm going to use those two numbers that I just found as coefficients to break apart the middle term. So that if we look at what we have, we can see that the only thing that changed in this polynomial is that my negative 18x is now written as plus 2x minus 20x, which is equivalent. If we were combining like terms, we would combine those to get negative 18x. Now I can factor by grouping, which means I take a greatest common factor out of the first two terms. That gets me an x. And factoring out that x leaves me 5x plus 2. And in my second group, I'm going to factor out a negative 4. Be sure to factor out a negative number anytime that your first term is negative. That applies to polynomials that you're factoring, or even a group that you're factoring by grouping. Taking out a negative 4 does change the signs of both terms so that I end up with 5x plus 2 in here. Now that I have a common binomial of 5x plus 2, which I can factor out, I can see that my other factor is created from the two green terms, which are my GCFs, so that my other factor here is x minus 4. Now recall that we are solving an equation, so we still have this whole thing equal to 0, and we're ready to do that last step, which is setting each factor equal to 0. X minus 4 equals 0, we may have caught on by now that it just changes sign when we solve it. The 5x plus 2 equals 0 might be a little bit more complicated, so let's go ahead and go through the steps on this one. We'll subtract 2 from both sides, and then we'll divide both sides by 5 in order to get x equals negative 2/5. You can certainly jump straight to the solution on something like this as well, because as we can see, we still have a sign change. The factor was all positive and the solution is negative, and we have a fraction that's made from these two numbers. The way to remember which one ends up on the top and which one ends up on the bottom is to imagine that if you were solving it, at some point along the way you would divide both sides by that 5. So the 5 ends up on the bottom. And this is my solution set. My solution set is the two values, 4 and negative 2/5.